Yeah. So coming to point of your basic types of passive elements, that is we used to call it as a RLC parameters. So in that case, just before entering into that, we will try to know the basic concepts of electric potential. So everyone knows that we call it is nothing but electric potential is nothing but work done per charge. So that is how much of work we have done with respect to charge. So we used to call it as a joules per coulomb. The definition is that ability of a charged particle to do work is called electrical potential. So ability of a charged particle to do work is called its electric potential. The unit of electrical potential is already what we call unit. We already know these basic points, that is this is a charge, this is a 1, so this is a 1 coulomb of charge. So what we call this is a basic part of this. So coming to point of your current, so already we know that without closed circuit your current will not go into a what we call circuit. So the circuit should be closed path. So electric current is a flow of electric charge. The flow of current does not take place if the circuit is open circuited. If the circuit is open circuited. So now coming to classification, how we classify the network elements. So we already know that there are active and passive elements. What are the active and passive elements over here? So active is your voltage and current case. So those are called, we used to call it as a sources, and the passive elements are called, we call it as a RLC, which consumes the energy. We used to call it as a passive, which supplies the energy. We call it as a active. We call it as a active. And coming to point of, there are another classification in that part. There is a unilateral and bilateral element. Unilateral, bilateral elements are something like this, where it will allow you to pass in one direction. We call it as a unilateral element. So if the current is able to pass in one direction, we call it as a unilateral element. So bilateral elements are the element is allowed to pass in both the direction. We call it as a bilateral element. Okay, coming to point of linear and non-linear elements. So linear and non-linear are something like this. So the voltage and current relationship of that particular element is linear. That is in terms of what we call linearity. We can call it as a linear element, or else it's a non-linear element. Another one is lumped and distributed parameters. So lumped is nothing but which is concentrated at one place. We call it as a lumped parameter, and which we distributed across the circuit. We call it as a distributed parameter. Example of this lumped and distributed is something like this. So you connected your wire from source to your element. Okay, that wire is also offering certain resistance. So that is called a distributed element. That is called distributed element. But you place one resistor into the circuit. So that is called a lumped element. Your understanding point. So lumped and distributed. So your wire offering certain resistance. We call it as a what we call complete wire is connected from source to the element. We call it as a distributed element, that one, because that is offering certain resistance. We cannot say it is a superconductor, is it not? So because of that reason, we call it as that is a distributed element. But the resistance offered by your element alone. So like you already know that 1 k ohm, 2 k ohm, 3 k ohm, the resistance which you have been connected into the circuit, we call it as it is a lumped parameter. Yeah. So this is just, I'm giving you some examples on this part. Active elements. So we already know that voltage and current source. So the notations have been very clearly given over here. So don't you should draw notations very clearly by using one higher potential, another one is lower potential. So this is your active element of voltage source. This is your current source. So this is a point of active element. And the passive elements, the resistance, inductance and capacitance part. So these are the three passive elements. So what we call, which actually the difference between the active and passive is, in the case of active you are supplying the energy, in the case of passive you are consuming the energy. Coming to point of your classification point, bilateral element and unilateral element. So bilateral, already I told you that what we call, when you take your resistance like this, Okay, this will resistance will allow current in this direction as well as in this direction. Your current is allowed in both the direction. Okay, so then we can call it as a bilateral element. Bilateral element. Are you able to understand my what we call concept? Is it clear?
Yes, sir.
Yeah, fine. Now coming to point of you take one diode. Okay, you take one diode. So what is this diode will allow you only in one direction, that is a conduction mode. That is conduction mode. So diode will pass a current in only conducting mode. Then we call it as a unilateral. It will not allow you to pass in other direction. It will not allow you to pass in other direction. We call it as a unilateral element. We call it as a unilateral. So classification is based on the current flowing through the element. That is in bidirectional, we call it as a bilateral element. We call it as a what we call bidirectional current flow. Unilateral element in the nothing but it's a unidirectional flow. So coming to point of linear and non-linear elements. So second classification is linear and non-linear element. Yeah, just you see that linearity. So when you draw a line between current and voltage, the linearity comes into picture. This is a linear element. This is a linear element. What is the example of linear element? Resistor is a linear element. Okay. Coming to point of non-linear element. Non-linear element is nothing but diode. So we know that forward bias, reverse bias, how it is going to become acted. All these things, the voltage and current relationship, VA characteristics of diode, if you draw, so you will get such a curve, such a curve. So this is called, this is not a linear. This is a linear. Linear in the sense, exactly proportional rate. That is a V is directly proportional to I. Such a variation will come into a picture. Then we call it as a linear element. We call it as a linear element. So this is a non-linear element. Diode is a non-linear element. Coming to point of lumped and distributed parameter. So just now I discussed that this is one battery. Okay. So we connected one resistor over here. One resistor over here. So actually this is a 1 kilo. 1 kilo. So what is this actually? This is called lumped parameter. Okay, lumped parameter. This is called lumped element. But the resistance offered by this wire which is connecting to your resistor. So your resistance might be connected over here. Is it not? So the resistance offered by this wire. So this is might be 20 ohms or 10 ohms or whatever it may be. So that resistance is called distributed parameter. So when you see the transmission line is running with some ACSR conductors. Okay, some bulk conductors they are running. So that conductor is also offering certain resistance, certain inductance and capacitance. So all these resistance, inductance and capacitance which is not physically what we call present over there, physically present, but technically it is a present. It is not present in physically, but technically it is present. So we call it as a distributed element. Nana point arthamavutunda? Lumped parameter and distributed parameter. Is it clear?
Yes, sir.
Yes, sir.
Yeah. Now coming to other important law, that is Ohm's law. Already, I think 8th class students will also explain you what is Ohm's law. Just it is a, but we need to take a consideration of at constant temperature. So at constant temperature we need to consider. So George Siemens, what we call Ohm, found experimentally. So how the voltage is related with the current in the case of circuit. So voltage across the element is directly proportional to the current flowing through the element. We call it as a V is directly proportional to I. We call it as a V directly proportional to I. Okay. So this potential across this is allows you to flow a current into the element. We call it as a Ohm's law. So I is equal to V by R because of this R, but we need to take constant temperature because resistance will vary as the temperature varies. We already know this. Yeah, coming to point of your resistance, this is already we know that resistance value. Actually, this is a standard symbol. standard symbol. Actually, when you see the student used to draw resistances like this. That's all. This is called resistance. Not no. So as a technically speaking, you should draw resistances like this: 3 peaks and 3 lows. Then we can call it as a that is a resistance symbol, not this. Okay. So this is not at all a resistance. That is the representation is always in a proper way. So resistance is one of the basic circuit element, so which opposes the flow of current and dissipates the energy in the form of heat. So we already know that what is a element which will because when you connect certain supply to the resistance will get heated up. Okay, you can observe that in the laboratories also. So when you keep on using your resistors, so when you taken out from the circuit board, you will sense a heat on the resistance element. Okay, so the resistance is usually represented by the symbol in this what we call whatever 3 peaks and 3 lows. The unit is already we already know that it is a ohm. It is a ohm. So we need to draw this ohm like this only. It is a Greek word. It is a Greek word. It is a ohm.
Excuse me, sir.
Yeah, Chopranna.
Can you please record the class, sir?
Forget to do that. Fine. Thank you, Amma. Thank you for remembering.
Thank you, sir.
So, what we call technical difficulties valla I could not able to make it out. Fine. I'll record the session. Yeah, is it clear now?
Yes, sir.
Yeah. Now coming to point of your resistance is over, and I need to find out the relationship between the V and I. So already we know that the drop according to Ohm's law is given in terms of what we call V is equal to I into R is equal to V by I. This is a what we call case, and this is one more loss of resistance I want to mention. So this is R is equal to rho L by A. So specific resistivity and the length of the conductor and the area of cross section. So if you take the area what we call any conductor which is something having a what we call like this, so you need to find out the area of cross section is this, length is this, area of cross section is this, and the length is this, and the material which has been made by this conductor, if you know, that is called specific resistivity of the material, then you can easily tell that the resistance offered by the material is given by, it's a loss of resistance which is called as a rho specific resistivity into L by A, into rho L by A. So this what we call will help you, because for example in the case of iron the specific resistivity is different, for copper it is different, for silver it is different. Okay, so based on the material which we will use, so based on that particular length, based on area of cross section, we will decide how much of resistance offered by that particular material. It is called as a loss of resistance, loss of resistance. So this is a specific resistance, length is the same thing, length of conductor, and cross sectional area in meter square, resistance offered by that. Yeah, coming to point of other element, what is that other element? Inductor. So you take any wire and you turn it as turn or twist, we can call it as a basic inductor. What is basic? What is inductor? Inductor is nothing but if you take one wire and you make it as a turns in the sense, just you make it as a rounds by turning it, you make it as some rounds. So we can call it as it is a coil. We call it as a coil. It is a basic inductor. It is a basic inductor. Not only copper, here he has given in terms of copper wire, but any inductor which can be made with even other materials also, we can make inductor. Okay. Actually, the inductor opposes the sudden change of current through it. It stores the energy in the form of magnetic field. It's an electromagnetic field form. So how it is going to become what we call stored energy, I'll let you know that, because when you what we call electrical element stores energy in association with the flow of current is called an inductor. You can define like this inductor. The inductor is nothing but it is a basic conducting material. If you take one wire and you make it as a turns, wire can be wound is nothing but make it as a turns, we can call it as a basic inductor. So, and it is what is the unit for the inductor? It is call it as a what we call Henry, and it is represented by H. It is represented by H. So here this is a core. Here you can see this circuit diagram. So this is your basic inductor part he has given in this fashion, and this part is called whatever the magnetic core which is mentioned. So there is some cases without magnetic core is also air will act as a medium. So you no need to use a core always. You no need to use a core. Core is nothing but it is a material which will allow you to transmit your energy magnetically from what we call. So because of that reason we use core in the form of what we call certain material, in the form of certain material. So this is called your inductor. Now coming to point of voltage and current relationship of inductor. So we already know that this is your inductor part, your current is flowing into this, once the current passes into this, what will happen to that? According to Faraday's laws of electromagnetic induction, whenever a conductor,
reverse current is generated by
reverse current
is generated by the inductor itself.
No. Let me first let me explain you basic of that. That is called flux linkages part. So your reverse current is in terms of back EMF, what we call in terms of machines it will come. So now you need to discuss in terms of flux linkages, because when the current passes through inductor, just you take one inductor, okay? If you take one inductor, or else before first you take one conductor, normal conductor. If the current passes into that, what will happen to this? There is a field around your conductor. Are you accepting this?
Yes, sir.
There is a field around the conductor. There is a field, magnetic field around your conductor. For example, if you are passing 1 ampere of current, then the field will be less. So if you are passing 10 ampere of current, the field will be high. So which factor is going to become decides the magnitude of field? Current is a parameter which will decide you the field, how much of magnetic field is present over there. Okay, in a similar way, when you pass a current into this, there is a field around this conductor. That is nothing but, what is a basic inductor? It is nothing but conductor which is wounded, and all this magnetic field is concentrated at one place in the form of magnetic field. We call it as that much of energy can be stored. So we call it as that is a flux linkages, number of turns linked with that particular flux. We call it as a psi. This is called a symbol which can be used as a flux linkages. Flux linkages are nothing but how much of flux. What is a flux actually? The field is just, I am saying that field, but field cannot be quantified. So you cannot say that this much of field is there. Okay. So to quantify that particular field, quantify in the sense to make a measure, we call it as a flux. We call field and flux both are similar terminology, but field is we cannot quantify the field. So because of that reason, we use a flux as to quantify. That is, we need to measuring quantity of the field. So flux is nothing but force of lines. Your force of lines. So when you force of lines is nothing but your flux. How much of flux is there in the sense? So how much of flux is linking to these conductors? What is this N? N is nothing but turn. So this is a one turn, this is second turn, this is third turn. Okay. So number of turns is this, and this phi is nothing but your flux. Flux per turn. How much of flux is per turn? So when you total flux linkages is proportional to the current through the coil. So now when the psi is nothing but flux linkages, how much of flux linkages is there? That is dependent upon proportional to the current flowing through the coil. Current flowing through is more, your flux linkages are more. Anyhow, the number of turns cannot be changed. Once the number of turns is fixed for any machine, you cannot change the number of turns. So because of that reason, your current flowing through will decide how much of flux is required, how much of flux will be present at in the machine. So psi is nothing but your flux linkages, that is nothing but N into phi, is directly proportional to I, and psi is nothing but Li. What is L now? It is an inductance parameter of the coil. Rate of change of current is proportional to the induced voltage. The meaning is that. So this is nothing but your value L. L is nothing but parameter which will decide you what we call give you the inductance property of the material. Inductance property of the material. There is nothing but in your case our coil. Now coming to point of already we know that rate of change of current, di by dt is nothing but rate of change of current. So rate of change of voltage is directly proportional to rate of change of current. So V is equal to L into di by dt. What is this L into di by dt? So with respect to times what we call di by dt, this inductance comes into the picture, and this dt, if the dt value with respect to time instant, if the dt is 0, what will happen to V? If the dt is 0, what will happen to V? What is the di by dt? Rate of change of current. Is it not? So what do you mean of rate of change of current? Yeah, the value V is going to become infinity actually. So because of that reason, the voltage across the inductor cannot change instantaneously. The meaning is that the voltage across the conductor cannot change instantaneously. See here current opposes the sudden changes of current. Inductor opposes the sudden change of current. See, di by dt. So this will not allow you to change of current instantaneously. This di value with respect to I, t value will never be 0. So it will not allow you to change the current instantaneously. It will allow you to change gradually. It will not allow you to change the current instantaneously. Okay. So current passing through the inductor is given by I is equal to 1 by L. Just I am doing this vertical integration on the both sides. So you will get I is equal to 1 by L V dt. Power in an inductor is given by P is equal to V into I. So V value is nothing but L into di by dt, and I value is nothing but what we call value is taken into I as usual. So Li by di by dt. Energy stored in inductor is given by W is equal to, there is a P into dt. P value is Vi. L into di by dt into I dt. So value is going to, once we solve this, you will get omega is equal to half Li square. This is the energy stored in inductor in the form of electromagnetic field. Energy stored in inductor in the form of electromagnetic field. Nana, clear I point to?
Yes, sir.
Yes, sir.
Yeah. So this is a voltage and current relationship of passive bilateral element. Why I am calling it as a bilateral element is nothing but inductor will allow you to pass in both the direction. So coming to point of capacitor, capacitor opposes sudden change of voltage. So here we can see that sudden change of voltage. There we have seen that it opposes the sudden change of current because of this equation. See, just you see V is equal to L into di by dt. dt will never be 0. Once it is 0, this is going to become infinity. Your understanding point. So because of that reason, it will not allow you to change of current instantaneously. But here it opposes the voltage, change of voltage. Capacitor opposes the sudden change of voltage. The meaning here you need to understand is sudden change of voltage. Their sudden change of current. Okay. Coming to point of your capacitor. What is a capacitor? There are two insulating what we call parallel plates separated by dielectric medium. We call it as a capacitor. And the energy stored in the capacitor, we call it as a electrostatic energy. Electrostatic energy. What is a dielectric medium which can be used in the case of capacitor? It might be mica, it might be your air, whatever you want. There is a dielectric material. Any dielectric material can be used to separating the. So basic definition of the capacitor is that two parallel plates separated by the dielectric medium, two parallel plates. So two conducting surfaces, frankly speaking, two conducting surfaces separated by a dielectric medium, we call it as a capacitor. What is the unit of capacitance? Farad. Already you know, so represented by F. So the same relationship have been taken. Current passes through the capacitor. The charge developed between the plates is proportional to the voltage across the capacitor. So Q is directly proportional to the V, and C is equal to Q by V. So ultimately current passing through the capacitor is given by I into dQ by dt. So dQ is nothing but CV. Q is nothing but CV. C into dV by dt. So just I am taking that into a voltage across the capacitor. I is equal to C into dV by dt. Integrating both sides, V into 1 by C, integration of 0 to t I dt. So power is taken VI, and just I am substituting C dV by dt into V. So just I am taking that energy stored in the capacitor in the form of electrostatic field is given. So half CV square joules. So here the energy stored in the inductor is given half Li square joules. So these are the two what we call, these are the two things, what we call energy storage elements. One is a capacitor, another one is inductor. In the case of inductor, the energy is stored in the form of electromagnetic field. In the case of capacitor, energy is stored in the form of electrostatic field. So this is again what we call, anyhow up to this point I'll stop today because some more discussion is there on this part. Till now, any doubts on this part, Nana?
No, sir.
Sir,
Chopramma.
sir, can you explain in some details, sir?
Detail?
Yes, sir. Means I'm not able to understand properly.
These are the why I'm Nana enduku koddiga ante casual ga veltunnanu indulo ante the reason is that already you know these basic things, no? So I don't want to spend more time on this part. Already you might be studied all these things. So meeku energy storage elements ivanni, these things are I think you are familiar with this, is it not?
Sir, that before part, sir, before inductor.
Before inductor. ఏది ఈ లంప్డ్ డిస్ట్రిబ్యూటెడ్ పారామీటర్సా?
Yes, sir. Lumped list.
Fine. అదే చెప్పాను కదమ్మా, లంప్డ్ డిస్ట్రిబ్యూటెడ్ ఇస్ వెరీ సింపుల్. డోంట్ వరీ మచ్ మోర్ ఆన్ దిస్ పార్ట్. దిస్ ఇస్ వెరీ సింపుల్ యాక్చువల్లీ. There are 4 types of elements: active, passive, unilateral, bilateral, non-linear, linear, lumped and distributed parameters. So actually దీనిలో మనం active, passive we know. What is that active and passive? Active is voltage and current case. Passive is RLC. So passive will consume the energy, active will supply the energy. So there are 2 types of elements, active and passive. Actually మనం active and passive మాట్లాడతాం a whole of your BE, but to make you to understand basic things, I'm just listing out all your elements, that's all. Okay, active and so you should know about what is active, what is passive elements. What is active element? Your voltage and current, which will supply the energy to the circuit. Okay, sources, we call it as a sources. What is a passive? RLC. So which will consume the energies. So resistance will consume energy in the form of heat. What we call inductor will consume energy, store the energy in the form of electromagnetic. Capacitance will store the energy in the form of electrostatic. Okay, na? That is the first classification. Coming to point of unilateral and bilateral. What is a unilateral? That is a flowing a current in one direction in an element. So మనం ఒక రెసిస్టర్ తీసుకోమా, ఒక రెసిస్టర్ తీసుకుంటే, so if the allows the current in both the direction, we call it as a bilateral element. So current ఇలా అయినా రావచ్చు, ఇలా అయినా రావచ్చు. We call it as a bidirectional element. Bilateral element, both are same. Bilateral or bidirectional element. అదే మనం when you take a diode will not allow you to pass in the opposite direction. That will not allow you to pass. Because of that reason, that is a unilateral element, only conducting, that is a forward bias only it will act. We call it as a unilateral element. So bilateral ante మనం ఏం చెప్పొచ్చు, రెసిస్టెన్స్, ఇండక్టెన్స్, కెపాసిటెన్స్ మూడు bilateral elements. యూనిలాటరల్ ఎలిమెంటే ఓన్లీ వన్ ఫార్వర్డ్ బయాస్ కండక్షన్ ఉంది కాబట్టి డయోడ్ అని చెప్తున్నాం. అండ్ కమింగ్ టు పాయింట్ ఆఫ్ లీనియర్ అండ్ నాన్ లీనియర్ వోల్టేజ్ అండ్ కరెంట్ రిలేషన్షిప్, మనం వోల్టేజ్ అండ్ కరెంట్ రిలేషన్షిప్ తీసుకుంటే, సో జస్ట్ యూ టేక్ ఎ వోల్టేజ్ అండ్ కరెంట్ రిలేషన్షిప్. If both are directly proportional, that is a V is directly proportional to I, in this condition we call it as a linear. ఎందుకంటే linear అని ఎందుకు అంటున్నాం, because the linearity comes into picture. Linearly it is varying. So V and I, this is your resistive element. So once it is varying proportionately, directly proportional, we call it as a linear element. Non-linear element, if you draw what we call voltage and current relationship of your diode, we call it as a non-linear element, like this. So it is not linear, frankly speaking. So generally when you consider the value of linearity, only resistance will comes into the picture. Okka resistor element manaku linear element, even inductor is also non-linear element, capacitor is also non-linear element. Okay, so that is a point of that. And coming to point of lumped and distributed parameter, అదే ఒక for example ఇప్పుడు when you take a, just now yesterday we discussed that resistances have been, this is one resistance, sorry, I'm poor in drawing, fine, anyhow. This is a lumped parameter. ఈ R అని మనం ఎలిమెంట్ ఎలా చెప్తున్నామో that is called lumped parameter. అంటే ఒక చోట కాన్సన్ట్రేట్ ఉండేదాన్ని lumped parameter అంటాం. మనం రెసిస్టెన్స్ ఈజ్ ఈక్వల్ టు 10 ohms అంటాం. వాట్ డూ యూ మీన్ ఆఫ్ 10 ohms? ద రెసిస్టెన్స్ ఆఫర్డ్ బై దట్ పర్టికులర్ ఎలిమెంట్ ఈస్ 10 ohms. అదే నువ్వు వేరే కండక్టర్ని తీసుకొని సోర్స్కు ఇటుపక్క సోర్స్ ఉంది, ఇటుపక్క లోడ్ ఉంది. సో ఇఫ్ యూ కనెక్ట్ దీస్ టూ, ద రెసిస్టెన్స్ ఆఫర్డ్ బై దిస్ ఈజ్ ఆల్సో 10 ohms అనుకుందాం. ఓకే, దిస్ ఇస్ సోర్స్ పార్ట్. ఓకే, దిస్ ఇస్ సోర్స్ అండ్ దిస్ ఇస్ అ లోడ్ పార్ట్. From this point to this point, one conductor has been connected. The resistance is not shown anywhere, but I am giving you the parameter R is equal to 10 ohms over there. So both are similar. R is equal to 10 ohms అని ఒక రెసిస్టెన్స్ లాగా మనం what we call నోటేషన్ ఇచ్చి మెన్షన్ చేసినా ఒకటే, R is equal to 10 ohms అని మెన్షన్ చేసినా ఒకటే. బట్ దిస్ పాయింట్ ఈస్ కాల్డ్ లంప్డ్ పారామీటర్ అంటాం, దీన్ని డిస్ట్రిబ్యూటెడ్ పారామీటర్ అంటాం. ఎందుకంటే ఇది ఒక 2 meters డిస్టెన్స్లో ఈ సోర్స్కు లోడ్కు ఒక 2 meters డిస్టెన్స్ ఉందనుకోమ్మా, ఒక వైర్లో కనెక్ట్ చేసాం దీన్ని. యువర్ అండర్స్టాండింగ్ పాయింట్? ఒక వైర్ తీసుకొని కనెక్ట్ చేసాం. దట్ వైర్ ఈజ్ మేడ్ విత్ సమ్ కాపర్ మెటీరియల్. దట్ కాపర్ మెటీరియల్ విల్ ఆఫర్ సర్టన్ రెసిస్టెన్స్. ఆర్ యూ ఏబుల్ టు అండర్స్టాండ్ దట్ పాయింట్?
Yes, sir.
Yeah, that is called distributed parameter. Is it clear?
Yes, sir.
Fine. Let me what we call these are the basic things. Just because of that reason, I'm just what we call gone through the case. Fine. Let me take the attendance.